very basic question. What is a scaffold and what it used for? A scaffold is any temporary elevated work platform and its supporting structure used for holding people, materials, or both. Scaffolding is used in new construction, renovation, maintenance, and repairs. OSHA categorizes scaffolds into three basic types. Number one, supported scaffolds. Number two, suspended scaffolds. And number three, other scaffolds. These other scaffolds have also different types. Hey, this is Javed, and you are on the platform of Safety First Life. Today we are discussing about basic types of scaffolds, associated components, and their specifications. If you are new on this channel, kindly subscribe it and press the bell icon. If you find the video informative, then like, comment, and share with your friends and colleagues. Let us jump on the main topic. Type number one, supported scaffolds, platforms supported by rigid, load-bearing members such as poles, legs, frames, and outriggers. Have a look on the left side of the slide. This structure is the example of supported scaffold. It includes handrail, guardrail, toe board, transom, standard, couplers, bracing, boards, base plate, sole plate, and ledger. Type number two, suspended scaffolds. In the suspended scaffolds, platforms suspended by ropes or other non-rigid overhead support. You can see on the left side, this is an example of suspended scaffold. Dear friends and colleagues, scaffolding have different load capacities. There are light duty, medium duty, and heavy duty scaffolds. Let us discuss first of all light duty. There are some conditions and limitations for light duty scaffold. Not to exceed 25 pounds per square foot. There must be 10-foot longitudinal post spacing. There must be 6-foot transverse post space. The most important thing here is different work levels. Number one work level, number two work level, and three work levels. In one work level, 8 additional plank levels and 125 feet maximum height. Two work levels, 4 additional plank levels, 125 feet maximum height. Three work levels, 0 additional plank levels, and 91 feet maximum height. In the medium duty scaffold, not to exceed 50 pounds per square foot, 8-foot longitudinal post spacing, and 6-foot transverse post space. Work level number one, 6 additional plank levels and 125 feet maximum height. Work level 2, 0 additional plank levels and 78 feet maximum height. In heavy duty scaffold, not to exceed 75 pounds per square foot, 6.5-foot longitudinal post spacing, 6-foot transverse post spacing. Work level number one, 6 additional plank levels and 125 feet maximum height. In this condition, maybe a safety practitioner or a general foreman, they will not understand what it means. But once I will go in detail, you will easily understand what is the difference between light duty, medium duty, and heavy duty scaffold and where it can be used. In the other type of scaffolds, there is freestanding scaffold. Freestanding scaffold is a scaffold which is not attached to any other structure and is stable against overturning on its own. This is an example in the photograph, freestanding scaffold. Another type of scaffold is independent tied scaffold, a scaffold which has two lines of standards. one line supporting the outside of the deck and one the inside. The transoms are not built into the wall of the building. It is not freestanding, being supported by the building. This is an example on the right hand side, independent tied scaffold. Another type of basic scaffold is foot-log scaffold. A foot-log scaffold is physically tied into the brickwork using footlogs or tubes with foot-log adapters. A slot is left between bricks to accommodate them, and once in place, the wall itself becomes the inside support. The outside support is formed by a series of standards and ledges. This is the series of standards, and this is the series of ledgers, and this is an example of foot-log scaffold. As you know, scaffolding is standing on base. So we are going to discuss now scaffold foundation. The foundation for a scaffold must always be adequate to carry and spread the load imposed. The load should be spread both locally at each standard and to collectively carry the whole weight of the scaffold. If there is a doubt about the surface, there should be a further spreading of the load by using sole board of timber or other suitable material. This is an example of sole board. The sole board beneath any one standard should be a minimum dimension of 450 mm into 220 mm into 36 mm. If the ground is soft or has been disturbed, the area shall be increased to 1700 centimeters square. What is 450? What is 220? And what is 36 mm? 36 mm is the thickness, 220 mm is the width, and 450 mm is the length of the plank. Let us start discussing about the sole board itself. There are different categories of sole boards. Number one, standard on immediate ground. Here the length will be 450 mm, width will be 225 mm, and thickness shall be 38 mm. In another type, if the standard is on soft ground, then the length shall be 760 mm, width 225 mm, and thickness 38 mm. If there are two standards, then the length is 1500 mm, 225 mm width, and 38 mm thickness. You can easily imagine thickness and width is same, but length is changing in different categories on intermediate ground, soft ground, or on the two standards, where the slope exceeds 1 vertical to 10 horizontal. Foundations may need to be checked to ensure scaffold stability. On soft ground, steps may be cut into the surface. In the case of sloping foundation on soft ground, level area must be cut into the slope twice the width of the sole board. The soil or ground must be well compacted beneath the sole board. If necessary, a kicker lift may need to be introduced for added support. This is an example of sloping foundation on a soft ground. Dear friends and fellows, here the ground must be capable of supporting the scaffold. The sole boards must be capable of spreading the weight of the structure without distortion. Sole boards placed at right angles to a building should not project too far beyond the face of the scaffold. Remember, sole boards should not be undermined. Sole boards should not become tripping hazards. These are the safety precautions you have to consider by considering the ground condition and the sloping angle. All scaffolds shall be erected on a firm level and consolidated base. No excavation should be carried out near to any scaffolding support. The reason is excavation can cause fatal collapse. You can easily identify here the scaffolding structure collapse due to excavation closer to the scaffolding structure. Scaffolding stands on foundation. Do you know the foundation faults? Bricks used as a sole plate, not resting on base plate, standard not grounded, supported by bricks and sole timber undermined, soft ground, no sole board, scaffold struck by vehicle, knocking it off the sole board and correct until the trench was put in place, sank. Sole board could bend and possibly break off center base plate. Here you can easily identify what are the foundation faults, where the foundation is kept. We are thinking and we are talking about firm ground surface, and this is the ground surface. You can easily identify. In this photograph, you can see also there is a trench and scaffolding is erected on the edges of the trench. What will happen? Once the load will increase, scaffold will collapse. Dear friends and fellows, before erecting any scaffolding, we have to determine the load classes that the scaffolding going to carry, the duty of that scaffold intend to use. And this can be achieved through controlling the distances between the bay length and spacing of board transoms. Now we will discuss about scaffolding assembly requirements. Independent load classes, very light duty. Very light duty scaffold is used for light work like inspection, access and painting. Load shall be uniformly distributed on the platform, 75 kg per square meter, one man plus tools, no material on the platform. What will be maximum number of loaded platforms? One full, 75 kg per square meter. Maximum bay length in the very light duty scaffold, 2.7 meter, and maximum spacing of board transoms shall be 1.2 meter. These are the specifications. Those are required to use the scaffold for its intended purpose. This is an example of very light duty scaffold. Here you can see the spacing between transoms and maximum bay length, as I told you, 2.7 meter, and maximum transom spacing is 1.2 meter. You can understand easily what is bay length and what is transom. Number two type of scaffold is light duty. Load class 2. Light duty scaffold is used for power, for cleaning, painting, and light engineering. Load distribution on the platform, 150 kg per square meter. 2 men plus tools. No material shall be on the platform. It can carry one loaded platform, 150 kg per square meter. Maximum bay length here is 2.4 meter, and maximum spacing of board transoms is 1.2 meter. This is an example of light duty scaffold. Let us discuss now the general purpose scaffold, number 3 type. It is used for general purpose like light engineering, welding or electrical work. Load distribution on platform, 200 kg per square meter. 2 men plus 175 kg material can be kept on the platform. Here you can retain one loaded platform and one 50%. Maximum bay length 2 meter and maximum spacing of board transoms 1.2 meter. This is an example of general purpose scaffolding structure. Number 4, heavy duty. This is class 4. Heavy duty scaffold is used for heavy engineering such as large pipe work or structural work. Here the load distribution on platforms, 250 kg per square meter. 2 men plus 250 kg of materials you can kept on the platform per square meter. Bay length here is 1.8 meter and maximum spacing of board transoms is 900 mm. This is an example of heavy duty scaffold where the maximum transom spacing is 900 mm and maximum bay length is 1.8 meter. Dear friends and colleagues, as I told you, very light duty scaffold is used for inspection, access and painting. You can keep the load of 75 kg per square meter, one man plus tools, but you cannot keep other materials on the platform. In the light duty, power cleaning, painting, light engineering, it can be the load of 150 kg per square meter. You can keep two men plus tools, but no material on the platform. Class number 3, general purpose scaffold. It can be used for light engineering like welding or electrical work. You can keep the load of 200 kg per square meter. Two men plus 175 kg material you can keep on the platform. And in the heavy duty scaffold, it is used for heavy engineering like large pipe work or structural work. You can keep 250 kg per square meter. Two men plus 250 kg of material you can keep on a platform. Dear friends and colleagues, we are talking about scaffolding assembly requirements. Standards must be plumbed to within 20 mm in 2 meter to a maximum of 50 mm throughout the full height of the scaffold. Bay length and width to within plus minus 200 mm on designated lengths, and lift height to be within plus minus 150 mm on the designated height. Joints in the standards and ledgers should be staggered so that adjacent standards ledgers are not joined within the same lift level. If it is necessary to join in multiple standards or ledgers in the same lift, then splicing will be required. Joints in ledgers shall be made with sleeve couplers and shall be positioned at a distance not more than 1/3 of the span between adjacent standards. Joints in standards shall be made either with joint pins or with sleeve couplers and shall be positioned near ledgers. This is an example of splicing standards and ledgers. The black marking is adjustable couplers, swivel type, and where there is the end of joining, the parallel tube, it is used as splicing. Did you know what is node point? All the braces and structural transoms to be connected with no more than 300 mm of the node point. Node point where the ledger, standard and transom intersects. This is node point. This is node point marked with circle, highlighted with red color. Another important element is tube projection. This is a general rule for all end couplers of any type, including check couplers. The tube should always pass through the end coupler by a minimum of 50 mm. This is the area that passed through 50 mm. This is tube projection, that is highlighted and marked with blue color. Let us discuss now the platform requirements. Main guardrail must be between 950 mm and 1150 mm from the boarded lift. The center one is the mid rail and the top one is top rail, and together it is called guardrail. Toe boards should be suitable and sufficient for purpose and a minimum of 150 mm. This is the example of toe board, and it should never be less than 150 mm. The scaffold class will determine the spacings of the intermediate transom board supports, that is in between 900 mm to 1.2 meter. The end transoms should be placed so that the board overhang is at least 50 mm and no more than 4 times the board thickness. The scaffold class will determine the width of the scaffold. This can be anything between 3 to 5 boards and up to 2 inside boards. An inside board can be fitted to extend the effective width of the platform and reduce the gap between the platform and the building. The standard spacing and board supports will determine the platform loading 75 kg per square meter to 250 kg per square meter. This depends on the duty of scaffold, type of scaffold, heavy duty, general purpose, or light duty. Here the inside boards have a maximum loading of 75 kg per square meter. Dear friends and colleagues, 3.9-meter boards should have a minimum of 4 transoms. Boards 2.7-meter or less require 3 transoms. In general, each board shall have at least 3 supports unless its thickness or span is enough to prevent sagging under load. Platforms with inside boards will normally have a gap of 50 mm. This is acceptable in tube and fitting scaffolds, providing a proper risk assessment is put in place, where men have to sit at the edge of the platform between the structure. The gap between the platform and the structure shall not exceed 300 mm. You have to remember these specifications. Have a look. This is an example of unsafe platform. Platform with broken or damaged plank, where materials are likely to be stacked above the height of the toe boards. Suitable barriers must be put in place to prevent materials falling off the scaffold. Guardrails and toe boards shall be positioned at every edge from which a person is liable to fall more than 2 meters. We were talking about scaffold platforms, scaffold foundation. Let us start discussing now about scaffold access. Landing areas must be kept clear of materials at all times. The access must be as small as possible. It is advisable to use a removable hatch to protect the access hole. Ladders must be secured near the top. The ladder must extend beyond the platform by 1 meter or 5 rungs. We are talking about this portion. 1 meter or 5 rungs should be above the landing platform. If a ladder extends by more than 9 meters in one run, rest areas or safe landing platforms must be provided. Ladders shall be kept on 75-degree or 4:1 ratio. Vertical ladders should be avoided unless they are in movable tower. The edges of landing places shall be provided with guardrails and toe boards. Ladders should be securely attached to the scaffold. This can be achieved using a variety of components and methods. All access points must have a grab rail or guardrail in place. The preferred ladder access is always internal of the scaffold. On soft ground, a sole board should be used. Never pack one side of the ladder. Never use packing to gain height. These are the important points. Those are related to scaffolding access. If you are interested to know about ladder safety, please click on the link that is appearing on your screen now. You have to position the access away from the main area where the concentration of work is being done. Ladder openings to a boarded lift should be no more than 450 mm in width, in length as small as practical, but at least 600 mm. Ladder openings need to be protected using guardrails or trap doors. Have a look here. The scaffold access is not safe. It cannot be used safely to access the scaffold structure. Dear friends and colleagues, you are watching Safety First to Protect Life. Our today's topic is basic types of scaffolding, their specifications. Now start discussing about scaffolding erection, alteration, and dismantling. Erection, alteration, and dismantling of a scaffold shall only be undertaken by competent scaffolders. This work shall be carried out under the supervision of a competent scaffolding foreman. Scuff tag holders (STH) of warning notices stating prohibition, scaffold incomplete, don't use shall be attached to all approved access points of a scaffold which are incomplete and not for use during erection, alteration, and dismantling. Don't use scuff tag should be positioned at earlier stage of erection, normally when the first bay has been erected. This is an example how you have to keep. Don't use scuff tag. The erection sequence of a scaffold shall ensure that at no time will the scaffold reach an unstable condition. Ties shall be fixed in place as erection proceeds, not when the scaffold is complete. While in alteration, all modifications to existing scaffolding shall be carried out in such a way that the stability of the scaffolding is not impaired. Supplementary components shall be added before those which have to be removed are taken away. If standards are to be removed in order to provide access, additional standards shall first be fixed on both sides of the proposed opening so that the total number of standards in the scaffold is never reduced. Prior to dismantling a scaffold, the scaffold shall be inspected and a safe procedure for dismantling is established by the scaffolding supervisor or foreman. During dismantling, no component, the removal of which would endanger the scaffold, shall be removed until steps have been taken to compensate for its removal. No items shall be thrown to the ground, lowering by hand only. If dismantling has reached the stage at which a critical member has to be removed, the stability of the scaffold shall be ensured by fixing a similar component in place lower down the scaffold. But remember, don't remove all the ties. Don't remove all the bracing first. Don't remove all the intermediate and board and transoms. And don't remove all intermediate guardrails. You have to remember these points. Otherwise, you may become victim of scaffolding, collapse, injury, or fatality. Now we'll start about scaffolding assembly sequence. First of all, you must know the measurements and marking of tubes like ledgers, transoms, and standards. The second step is you have to setting out material, what you are going to plan, what you are going to do. Accordingly, you have to keep the material like standards, transoms, ledgers, and base plates. Then you have to start with kicker lift. Then you have to keep first lift ledgers and transoms. But you have to ensure the level of the scaffolding structure. Then you have to start first lift sway bracing where there is red circle. This is the example of first lift sway bracing. Have a look. This is an example of ledger bracing. After ledger bracing, you have to go step or half lift. At the top, marked with red, you are keeping main guardrail. In this slide, here you are going to start raising boards. This is an example of raising boards. Here you kept intermediate guardrail and toe board. This is toe board and this is intermediate guardrail. This is also intermediate guardrail, means mid rail. Dear friends and colleagues, scaffolding structure need to be tight, and this is only possible with the help of scaffolding ties. Ties play an extremely important role in providing stability to scaffolding structures. Several methods of attachment are used. Ties rely on these three requirements and ideally need to prevent movement toward and away from the structure and also in lateral movement. Pull away from the building, push towards the building, sway along the building. The capacity of the tie is determined from the lowest value of number one, the load bearing capacity of the building fabric. Number two, the capacity of the connection between the tie tube and the building. And number three, the capacity of the connection between the tie tube and the scaffold. The connections between the scaffold and the building are achieved by fixing tie tubes to the scaffold standards or ledgers. Right angle couplers to be used. These connections should be made within 300 mm of a node point. Otherwise, design advice should be sought. This is an example of tie, and these connections shall be made within 300 mm as I discussed. Let us start discussing now the types of ties. Very light duty tie, rakers. Very light duty ties have a capacity of 2.7 kilonewton or less and are formed by rakers. Rakers may be used in place of ties at the first or second lifts of a compliant independent scaffold. If the scaffold exceeds 6 meters, the remaining lift must be tied as usual. A single unjointed raking tube not more than 6 meters in length may be coupled at the top to the ledger at the second lift. The raker must no exceed 3 meters unsupported. The foot of the raking tube must be well founded and tied back to the main scaffold. Where it is not possible to provide normal ties, the stability of the scaffold can be achieved by using rakers. If it is a tall structure, rakers may not be enough. You may need a buttress. Now we'll talk about light duty tie, reveal tie. Light duty ties have a capacity of 3.5 kN or less, are formed by using reveal pins. This is the shape of reveal tie. No more than 50% of the ties to a facade should be reveal ties. Regular checks should be made through the life of the scaffold to ensure that the reveal ties are tight. The tie tube should be fixed to the reveal tube within 150 mm of the opening opposite the reveal pin and within 300 mm of the node point. This is node point, and this is the reveal tube within 150 mm. Let us start discussing about the standard duty ties. Standard duty ties have a capacity of 6.25 kN. These should be connected to the scaffold. Ledgers are standards with right angle couplers. These ties can be formed by means of lip, box, or through ties. This is the shape of standard duty tie. Standard duty lip tie consists of L-shaped arrangement of tubes and couplers which hook behind a convenient part of the building of adequate strength. Have a look. This is standard duty box tie. This is the shape of box tie. If you are going to inspect a scaffolding structure, you must understand which type of tie is being used. If you are going to make a report, how you can. If you are not able to know what are the different types of ties, those are being used in the scaffolding structure. This is an example of standard duty through tie. Right angle couplers. The most important type of ties is heavy duty tie. In heavy duty tie, each tie assembly for sheeted scaffolds shall have at least a 12.5 kN capacity. The capacity of heavy duty tie is more than light duty and standard duty ties. Have a look. This is an example of screw or anchor ties. Anchorage points for scaffold ties can be built into the fabric of the building, and a wide variety of screw plates, sockets, and nuts are available to be used on different types of materials. Capacity is 25 kN or as recommended by manufacturer. This is the most powerful with bigger strength screw or anchor ties. In the anchor ties, there are also ring ties. This is an example of ring tie. Dear friends and fellows, after discussing different types of ties, their strength and classification, let us understand the general guidance about the ties. Ties are generally spaced at 4-meter intervals, both horizontally and vertically. The ties should be set out to occur on a braced pair of standards and fixed with load-bearing couplers within 300 mm of the nude point. The duty and number of ties will depend on the intended use of the scaffold and how long it will be in position. Loading which will be imposed on the scaffold, the overall size and height of the scaffold, if the scaffold is sheeted or netted. These are the important points, and you can use different types of ties based on these configurations, requirements, or conditions. Line of ties on alternate lifts, ties spaced at 4 meters, both horizontally and vertically. 50% of ties on ledger braced frames. As a general rule, for positioning of ties on a basic scaffold structure should be no more than 6 meters square. Let us discuss now the ties position. General tie pattern. All sheeted scaffolds will require the top lift to be tied. A tie position at a cantilever section now becomes critical and must not be removed. The tie position for the cantilever section will depend on the location of the support. Remember, in the removal or the replacement of ties, scaffold ties should only be removed and replaced under the supervision of an experienced and competent scaffolder who will be aware of the dangers and capable of making alternative arrangements to safeguard the stability of the. Critical ties are used where ledger to ledger braces removed, where protective frames erected, where cantilevered stage is erected, in center of bridged scaffolds. Dear friends and fellows, we are talking about scaffolding ties. Let us discuss what to do in routine checks of scaffolding ties. Can the scaffold move away or towards the building? Are all the ties fixed with load-bearing couplers? Are there a sufficient number of ties correctly positioned? Are all the critical ties intact and secure? Have any alterations been made to the scaffold? Have the revealed ties been physically checked and tightened? Always double check the ties after adverse weather conditions. If you are in doubt, seek advice from the experts, the scaffolding supervisor or the scaffolding engineer. After discussing the scaffolding components and basic type of scaffolding, let us start discussing raising and lowering material. All lifting equipment should be used, examined and inspected in accordance with LOLA. All gin wheels, ropes and accessories for lifting, including bags and buckets, must be identifiable and regularly inspected. These are the examples of lifting equipment: lifting buckles, bags, and ropes. All lifting equipment should be inspected before use to ensure that they are in good condition. The wheel should run freely and true with no visible signs of corrosion, excessive wear, deformity, or contamination from oil, paints, concrete, etc. The ropes are in sound condition, are not cut, frayed, worn, or damaged. As you can see in the photograph, this rope cannot be used in any case. Scaffolding materials may be raised and lowered manually using one of three typical methods. Number one, they may be passed hand to hand, known as handball or chaining. Number two, a hand line may be used, typically a 12 diameter fiber rope. Hand lines are suitable for lifting material of up to 20 kg. Number 3, chin wheel and 18 mm diameter fiber rope, suitable for lifting materials of up to 50 kg. But remember, you should never lift or pull up more than you feel comfortable with. As you know, we are talking about raising or lowering material on a scaffold structure. Do you know how to install gin wheels? The suspension point of a gin wheel should be no more than 750 mm beyond the outer standard. Ring type gin wheels should be secured with right angle couplers either side of the suspension point. Ideally, the suspension tube should be supported on two standards extending above the working lift. If a joint occurs on the inner standard, a sleeve coupler should be used. Support tube must be fixed with right angle couplers, doubles or swivels. Front tube is under compression. The back tube is under tension. If there is a joint in back standard, it must be spliced. Try to install your gin wheel on a braced pair of standards. Dear friends and colleagues, you can identify here the violation. This type of violations are common in the construction sector. This gentleman who is going to advise the scaffolders, they are working at height. Look at this gentleman. What is his condition? Definitely, he is a senior person, senior professional, maybe a project manager or a site engineer or a construction manager. And this is the condition of housekeeping. Let us start discussing about tower scaffolding, how to construct freestanding tower. Dear friends and colleagues, towers must be erected on firm and level foundation. A footlift is recommended for safety. The ledges and end transoms must be connected with right angled couplers. Board bearing transoms will be connected with single couplers. The lift heights should not exceed 2 meters. The tower should be braced on all four sides. Alternate lifts should be plan braced, including under the top lift. In the freestanding tower, only one working lift is permitted. Ideally, joints should occur in the upper lift. Ideally, joints should be made with sleeve couplers. Bracing on internal towers should be within 300 mm of node point. Bracing on external towers should be within 100 mm of node point. External or towers exposed to the wind may not be netted or sheeted. The ladder shall extend at least 1 meter above platform level. A ladder for access purposes shall be lashed vertically to one of the narrow sides inside the base area, with the foot resting on an additional transom. After discussing freestanding towers, let us start discussing movable towers. Movable towers mounted on casters must be erected on firm and level ground. Casters must be of equal load bearing capacity and fitted with a brake and a means of attachment to the scaffolding. The SWL, safe working load of the wheel, should be stamped on the frame. Wheels must be 125 mm minimum diameter. Wheels must have brakes and lock nuts. Movable towers shall be moved only by pulling or pushing at the base. Do you know the tower scaffolding height? Dear friends and colleagues, the maximum height established shall be height of the working platform, not the guardrail. The maximum freestanding height for movable towers shall be 8 meters and for static towers 10.8 meters, where the maximum freestanding height or the maximum recommended height to the base ratio requires to be exceeded or the tower is likely to be exposed to the appreciable wind loading. The scaffolding shall be tied to the structure it is serving or designed to ensure stability by means of ground anchors, guys, or cantilever. After discussing freestanding and mobile towers. Let us start discussing now special scaffolds. All scaffolds over 50-meter high and all sheeted scaffolds over 25-meter high, together with hanging, birdcage, truss out, slung, cantilever scaffolds, hoist towers, loading bays, and protection fans shall be designed by a competent civil engineer in accordance with the requirements of British Standard Specification Number BSEN 12811/NASC TG20 as based on BS 5973 or acceptable equivalent. The engineer shall provide a written erection and dismantling procedure together with the scaffolding drawing and his design calculations. These are the limitations, these are the requirements must be complied with. Dear friends and colleagues, prior to erection, the scaffolding supervisor or foreman in charge of the works shall inspect the ground area upon which the scaffold is to be positioned and shall inspect all equipment which shall form any part of the scaffold staging, means of access, work platform, and lifting gear. Such inspections shall also be required daily during use. The scaffolding supervisor shall appoint a competent scaffolder to be solely responsible for maintenance works on scaffolds and staging. Prior to persons being allowed to use scaffolds or staging, or where they are altered, adjusted, or subjected to rain or heavy winds, and thereafter at least every 7 days, the qualified inspector shall inspect the scaffold inclusive of peripheral equipment. On satisfactory inspection, the inspector will sign and date the reverse yellow side of the scuff tag and shall record his findings in the scuff tag inspection register. These are the examples of green and yellow scuff tag. I have already given you a short introduction of scuff tag and tagging procedure in the previous video, part 3 of scaffold safety. Today we'll discuss in detail what kind of tag shall be used once the scaffolding is under construction. During construction, the scaffolding supervisor or the competent scaffolder must fix scuff tag holders STH to all approved access points to the scaffold. When the scaffold is incomplete, the scuff tag holders showing the international prohibition symbol and the script down to use scaffold. The information will apply to all personnel not involved in the scaffold construction. All the scuff tag holders and inserts should be weatherproof. Once the construction of the scaffold is completed, what to do? When the construction is completed, the scaffolding structure is inspected to ensure compliance with statutory legislation and codes of practices. If satisfied, the qualified inspector completes the green face scuff tag, which means the scaffold is safe for use, and this is the shape of safe for use scuff tag. Do you know what data scuff tag is containing? Date, erected, with name, competent scaffolder, and initials of scaffolding supervisor or foreman. Maximum loading capacity. Date inspected, with name and initials of qualified inspector. All these information are available on scuff tag. All entries onto the tag shall be made with a permanent ink pen. All personnel who come into contact with scaffolding shall be trained in the use of the scuff tag tagging system. It may be the qualified inspector responsibility to enter the details and conditions of scaffolds inspected into a scaffold inspection register. On satisfactory inspection, the qualified inspector will sign and date the reverse yellow side of status scuff tag and update the scaffold inspection register. It is the responsibility of scaffold user to ensure the scaffold is showing safe to use, and within the inspection dates, any scaffold found not to have a scuff tag in place, overdue inspection, or in the prohibition state must be reported immediately for verification to their concerned supervisor. Dear friends and colleagues, scaffolding inspection is mandatory, but when to do? When the place of access is first put into service, after modification, after adverse weather conditions such as snow and wind, or no greater than 7-day intervals. These are the occasions or the conditions or limitations for scaffolding inspection. Dear friends and colleagues, I'm going to give you scaffolding general requirements. In short, number one element is footing or anchorage. The footing or anchorage is to be on a solid foundation, sound, rigid, and capable of carrying the maximum intended load without setting or displacement. Point number one, this is very, very important. This is a general rule. The use of unstable objects to support planks or scaffolds is prohibited. Number two, guardrails. The use of guardrails is very important, preventing workers from falling. Nearly 3 upon 4 of the reported scaffold incidents or accidents are caused by improper guarding. Open-ended or open-sided platforms must have standard guardrails and toe boards. The guardrails are to be 2 into 4 and about 42-inch high with a mid-rail whenever needed. The supports for the guardrails are to be at intervals no more than 8 feet. You have to remember these points. You can check during your inspection on site as a HSC practitioner, as a safety officer, or a safety supervisor. Point number 3, safe access. All scaffolding structures must have safe access. Cross braces prohibited as means of access. Bottom rung no more than 24-inch high. Rust platforms required at 35 feet intervals. Slip-resistant treads on all steps and landings. Hook on attachable ladders, specifically designed for type of scaffold. Lowest rung no more than 24 inches above level on which scaffold is supported. Rust platforms at 35-foot interval when more than 35 feet high. Minimum rung length 11.5 inches and a maximum space between rungs shall be 16.25 inches. There must be the provision of ladders for accessing platforms. Foundations must be firm and level. Angle of about 75 degrees, 4 vertical to 1 horizontal, and projecting at least 1.05 meter. Point number 4, protective screening. Overhead protection shall be provided for men on scaffolds, and in the same sense, a screen is to be placed below the scaffold where persons may be in danger of falling objects. Point number 5, safe platforms. The planking is to be of scaffold grade wood or metal, free of defects that may contribute to an accident or incident. The planking shall be overlapping or secured from movement, extending not less than 6 nor more than 12 inches over their end supports. Vertical members standing perpendicular to horizontal. Fully planked or decked with gaps no greater than 1 inch, able to support its weight and 4 times the maximum load. At least 18 inches wide. And remember, scaffold should be designed by temporary structurer. No paint on wood platforms. Use scaffold grade wood, fully planked between front upright and guardrail support. Component pieces used must match and be the same type. Erect on stable and level ground. It should be nailed properly, otherwise it may be toppled. In this photograph, you can see the planks are not properly overlapped. It may lead to a potential falling incident. Each end of the platform, unless cleated or otherwise restrained by hooks, must extend over a support by at least 6 inches. Side and end brackets are designed to support people only. And remember, never overload platforms with materials. The height of the scaffold should not be more than 4 times its minimum base dimension, unless guys, ties, or braces are used. With a width of 5 feet, this scaffold cannot be higher than 20 feet. If it is a supported scaffold, platform supported by legs, outrigger beams, brackets, poles, uprights, posts, and frames, restrained from tipping by guys, ties, or braces. Scaffold poles, legs, posts, frames, and uprights must be on base plates and mud sills or other firm foundations. You have to remember these points. This is base plate. This is mud sill. Here you can see good support is not provided. And in the downside, this is totally unacceptable. The supporting foundation is not sufficient. It may cause collapse to the scaffolding structure. Here you can see the common faults in the scaffolding. This is an example of bent tube. You cannot use it. This is an example of split end tube. You can easily imagine this type of deficiencies. You can easily identify the damaged or faulty components of the scaffolding structure. This is an example of mushroom-headed tube. This is cross-cut tube, and this is flame-cut tube. And these are the faults. Once these type of components are tried to be fixed within the scaffolding structure, once one component is going to fail, it can collapse the whole structure. These are the different types of defective tubes. Dear friends and colleagues, what to look for when inspecting boards free from dangerous knots. Bended both ends, free from burns, cuts, nails, checks, oils, or splits, not wrapped. Be on the normal weight, free from natural flaws such as cross grain. You have to see all these points once you are going to inspect boards twisted, wrapped, broken, split, worn, damaged. I'm going to give you now the scaffolder's personal protective equipment, full body harness with double lanyard. This is double lanyard and this is full body harness. Full body harness with double lanyard used as fall arrest during erection and dismantling of scaffolding. Full body harness and lanyard should be inspected before use. It must be replaced when involved in a fall. Ensure that always one lanyard is connected at all times when moving. This is also the personal protective equipment for scaffolders. Knitted rubberized hand gloves used to protect hands during handling of scaffolding materials, used to increase grip on scaffold materials to avoid slippage. So these type of gloves, PFAS, personal fall arrest system, full body harness with double lanyard is mandatory and must be worn during erection and dismantling by all the scaffolders, including the scaffolding in charge, supervisor or foreman. Dear friends and colleagues, after discussing in detail about the scaffolding safety, now I'm going to tell you the bad practices, how you can identify the failures or the lapses. Here you can see the different arrows and circles. The status is lack of mean of access, no platform edge protection. There are overhead obstructions. What you will recommend here? I will recommend here regular inspection, safe working load, competent staff, safety equipment working, platform edge protection, guardrails and toe boards fitted, adverse weather rules, protected electricity supplies, communication emergency procedure. Once you are in a scaffolding structure, you have to identify the bad practices, the unsafe work practices that might lead to a potential accident. Another bad and substandard activity, using unsafe scaffolding with red tag. You can see the tag here and they are using it. I will recommend here implement work permit system and erect scaffolding with certified scaffolding supervisor. They must know what is the meaning of different type of tags. Here again, look, different circles. These are the indications of bad practices, unsafe work practices. On the left hand side, there are 3 points. You can see here, there is no base plate, no platform, edge protection, no stair for access. On the right hand side, no base plate, no platform, edge protection, no stair for access. This is another example of unsafe work practices. On the upper side, no base plate. This type of practice may unbalance or topple and cause fatal accident. Dear friends and fellows, here again, the broken base plate, not fit for carrying weight, may unbalance and topple the structure. On the right hand side, lack of means of access, no platform edge protection, and these structures are not safe for use. If I'll tell you in short, you have to look. If you are going to inspect a scaffolding structure as a safety supervisor, as a safety officer, or a safety engineer, you have to check the following points. Number one, handrails installed or not. The structure is secured or not. Knee rails installed or not. Kick or toe boards in place or not. Trapdoors installed or not. Working platforms complete or not. Ladder or step ladders installed or not. Scaffolding permit signed or not. Scuff tags, green tag displayed or not. Foot plates installed or not. Cross bracing in place or not. If you will check these 11 points, it is easier for you to understand whether the scaffolding erection is safe or not. Have a look. This is an example of a good scaffolding structure. This is a good practice. Have a look. This is the professional work. A good example of solid scaffolding structure. Dear friends and colleagues, training session related to scaffolding safety, part 4, that was about the types of basic scaffolding with specifications and technical information with general safety rules and requirements is over now. If you have any question, please ask in the comment section. Thanks for watching, and don't forget to like, comment and share the video. Hope to see you soon with a new HSC tutorial. Till then, take care, good luck and Allah Hafiz.